Dear students, I am Mahesh Javalkar from Marathaman Polytechnic. So I am posting today my seventh video on semiconductor devices MCQ, and in that continuation we'll see the next question. So the next question, question number 131, during forward bias, the PIN diode acts as what? Okay. Now the PIN diode is a diode which is having P type of material, intrinsic material, and N type of material. Okay. And that intrinsic material is making a it is adding to the depletion layer. Okay. Now when you forward bias the diode, the depletion layer will decrease. That means the resistance across the diode will decrease. Okay. That means when it is forward bias, PIN diode acts as a variable resistor. So here the option should be option a variable resistor. Okay. Next we'll go to the next question. Question number 132. During reverse bias, the PIN diode acts as. Okay. Now during reverse bias, we again have the same structure, P type of material, intrinsic material, and N type material. Reverse bias, that intrinsic material is adding to your depletion layer. Now there is a layer, depletion layer, which is not allowing any current to flow like an insulator between P type and N type semiconductor. Now if between two semiconductors, if there is an insulating layer, then you can view like a capacitor. So it can be a variable capacitor. So during reverse bias, the PI acts as a variable capacitor. So here the option will be C, variable capacitor. Okay. Then we'll go to the next question, question number 133. Which of the following is true about PI? Okay. Now, if you see the options, option A says that it's photosensitive in reverse bias. It offers low resistance and low capacitance. It has a decreased reverse breakdown voltage. And D1 is carrier storage is low. Okay. I think the first one is the correct one because a PI diode is usually used in reverse bias as a photosensitive device. Okay. It will take light as an input and convert it into electrical energy. So if you want to convert light into electrical energy, you can use a PIN diode. It can also be called as photodetective. Okay, so the option A, it is a photosensitive in reverse bias. It is true about PIN diode. Okay. Then we'll go to question number 134. Schottky diodes are also known as. Okay. If you remember the structure of Schottky diode, it is a metal and a N-type semiconductor. A metal and a N-type semiconductor. There is no P-type semiconductor here. It is a metal joined to an N-type semiconductor. Whenever this type of arrangement is done, the majority carriers in both are electrons only, but the N-type semiconductor electrons have high kinetic energy and they enter the metal, and that entering is called as hot carrier. Hot carriers are entering. Okay, so it is hot carrier diode. So Schottky diode can also be called as hot carrier diodes. Okay. Then we'll go to question number 135. What is the best choice of IC package used for experimental purpose? The experimental purpose, if you see the basic experiments in your basic DC labs also, if you're using gates like your NOT gate, AND gate, okay, NOR gate, OR gate, XOR gate, any the gate you see, it is a parallel types of pins. You can see 7 pins on one side, 7 pins on other side. Okay. Even if you take a microcontroller, okay, in that also if you see 20 pins on one side, 20 pins on other side. Even if you take a 8086 microprocessor, 20 pins on one side, 20 pins on other sides. So that type of arrangement where you have a half of the pin on one side and half of the pin on the other side, which is very useful in experimental purpose. It's called as dual inline package. Dual inline package. So it is DIP. So here the option will be dual inline package, DIP package. Okay. Then we'll go to question number 136. An IC has dash size. Okay. Now, integrated circuits best advantage of having an IC is its size is very small. So here the option should be extremely small. So C, extremely small will be the option. And IC has extremely small size. Okay. Then we'll go to question number 137. ICs are generally made up of. Okay. Now, as we know that out of the two best semiconductor materials available, silicon and germanium, silicon is more available in nature and its thermal stability also is better than germanium. So ICs are generally made up of silicon. Okay, so here the answer should be A, silicon. Then we'll go to question number 138. Dash ICs are most commonly used, whether they are thin films or monolithic, made from one lithic or hybrid or none of those. Okay, I think the most common ICs used are monolithic. So B should be your answer, monolithic. So monolithic ICs are the most commonly used. Then we'll go to question number 139. Dash cannot be fabricated on an IC. Okay, now on an IC, we have studied in our semiconductors that we can fabricate a transistor, we can fabricate a diode, we can fabricate a resistor, but we have not studied large inductors or transformers where coils are there. Those things we cannot fabricate on an IC because it is very bulky and coils are there. Then the coil effect also you have to produce. All that is not done on an IC. So here the option will be option D. Dash cannot be fabricated on ICs. Large inductors and transformers cannot be fabricated on an IC. Okay. Then we'll go to question number 140. The active components in an IC are, the options are resistors, capacitors, transistors and diodes, and none of them. Obviously, the active components will be transistors and diodes because rest all are passive components. Okay, so here the option should be C, option C, transistor and diodes. Okay. Then we'll go to question number 141. The SiO2 layer in IC acts as. Now SiO2 layer we have seen in MOSFETs also. Okay, it is an insulating layer. It is an oxide layer. Okay, so it is an insulating layer. Okay, so here in these options, option B will be an insulating layer. The SiO2 layer in an IC acts as an insulating layer. Okay. Then we'll go to the next question, question number 142. Which of the following is most difficult to fabricate in an IC? Okay. Now options if you see here, diode, transistor, FET and capacitor. Diode we can fabricate, transistor we can fabricate, FET also we can fabricate. But fabrication of capacitor is little difficult and therefore here option will be capacitor. So here, which of the following is most difficult to fabricate in an IC? That is a capacitor. Okay. Then we'll go to the next question, question number 143. SSI refers to. Okay. Now, if you see integrations of IC, the first type of integration will be small. That is called a small scale. Okay. Second will be medium scale. Third will be large scale. And fourth will be very large scale. Okay. Now SSI will refer as small scale integration. So here the option will be option A. Okay, it is small scale integration. Now SSI will be in the range of having components or gates from 1 to 10. Okay, medium scale will have from 11 to 100. That is about 10, but 11 to 100. Then large scale will have from 101 to 1000 and very large scale will have above 1000. This range you have to remember for any type of objective questions asked on integration. Okay, so that we'll see now. We'll go to the next question, question number 144. Small scale integration, SSI, refers to IC with dash gates on the same chip. Okay, so as I've told you, small scale integration will have from 1 to 10. So it is fewer than 10. So option A will be correct, less than 10. Okay, so small scale integration will have less than 10, that is 1 to 10. And medium scale will have 11 to 100. Large scale will have 101 to 1000. And very large scale will have above 1000. This is what a basic range you have to remember to answer these questions of integration. Then we'll go to the next question, question number 145. MSI means. Now, as I've told you, SSI was small scale, MSI will be medium scale integration. So here option C will be medium scale integration, MSI. Okay. Then we'll go to the next question, question number 146. MSI includes gates per chip. Now, how many gates per chip MSI is including? Now, as I've told you, small scale was from 1 to 10. MSI will be from 11 to 100. Okay, so if 11 to 100 if you're taking, then here option is 12th one where it is telling 12 to 100. So that you can mark as the option for this. Okay, So MSI includes gates per chip is 12 to 100. Okay, it can also be 11 to 100, but it is more than 10 and less than 100. Okay, then we will go to the next option, option number 147, large scale integration. LSI means large scale integration. Okay, and it refers to how many gates per chip. Now, as I've told you, small scale integration was from 1 to 10, medium scale was from 11 to 100, then large scale will be 101 to 1000. So it will be less than 1000 and more than 100. Okay. So the first LSI means the full form of LSI will be large scale integration, and the gates per chip will be between your uh, this thing more than 100, okay, and less than 1000. So I have said 1000, you can take it as 5000 also, because very large scale integration is growing a day by day. So here you can take the, out of these four options, you can take option number B. The meaning of LSI is large scale integration, and it refers to gates per chip is more than 100. That is right. Up to the larger range here, we have increased to 5000, because very large scale integration can go above 1000, can go above 5000 also. Okay. So option B you can mark here. So here is large scale integration has more than 100 up to 5000. Okay. Then we'll go to next question, question number 148. The full form of DIPs. As I've told you earlier, the common ICs what we use in our digital electronics lab also are DIP. The microcontroller what we have used 8051, the processor 8086, all are DIP in nature. DIP means dual inline package. Okay, dual inline package. So here the option will be B, dual inline package. Okay. Then we'll go to question number 149. What type of integration is chosen to fabricate integrated circuits like counters, multiplexers, and adders? Okay. Now these type of circuits, counters, multiplexers, and adders, have gates or components more than 10, okay, but less than 100. So that range has to be a medium scale integration. So here the option should be B, medium scale integration. Okay, counters, multiplexers, and adders come under medium scale integration. Then we'll go to question number 150. Which integrated circuit is having more than 1000 gates? So as I've told you, uh, earlier definitions used to tell that integrated circuits more than 1000 were called as VLSI. But now even 5000, 10,000 means it is increasing. It is increasing. It is doubling every 18 months. Okay. So here more than 1000, if you are having integration of more than 1000 gates or components, it is called as very large scale integration. So option will be D, very large scale integration. Okay, students. Now these were some of the questions which were on Schottky diode and your PIN diode and your fabrications and your medium scale, large scale, very large scale, small scale integrations, that is integrated circuits. Okay, students, we'll stop here, and this is your last question in this video. If you're having any doubts in this, you can put a feedback or you can drop a comment on that. And again, I will tell you the same thing. See that your basics are very clear. Of any subject, if you want to attempt any objective type of question or multiple choice question, the basics of that subject should be very clear. So read more and more basic books first, and then go for the higher things of that subject. Okay, thank you very much, students.